Hi, my name is Evan Liette, and today we are going to be talking about H-NMR and IR unknowns. First off, we're going to be starting with H-NMR, and my unknown is N39. Experimental procedure. I recorded a proton nuclear magnetic resonance spectrum of an unknown sample. The sample was dissolved in deuterated chloroform CdCO3 and measured at room temperature. Labeling the spectrum, chemical shifts. So the first chemical shift we have right here is 3 to 4 ppm. This indicates adjacent to electron negative atom. The next one we have is the 7.6 ppm and 8.2 ppm. This indicates an aromatic ring. As you can see the range right here. Labeling the spectrum. So for the first peak, we have around 4.0 ppm, and then that is consistent with an OCH3 group. And then we also have a combined aromatic region here, combined integral of 5H. This is consistent with 5 aromatic protons. Labeling the spectrum. So first we have a singlet right here as one strong peak. And then we move on to the aromatic region where it is more complex multiplets overall appear as overlapping doublets and multiplets. As you can see, this looks like a doublet and here's a multiplet. Selection of compounds. So now that we know we have an aromatic ring, we can take away any of the unknown compounds or possible unknown compounds that don't have an aromatic ring. And I did this beforehand. The splitting pattern correlation is correct because of the OCH3 singlet. And then I drew out the aromatic ring along with the double bonded oxygen. And this single bonded oxygen correlates with the OCH3 becoming combined. Our final identification. So we know we have our singlet here and our aromatic ring. Our final thing is to identify which unknown ours is. It will not be this because it does not have a double bond or an oxygen on it. While this might have a double bonded oxygen, it does not have the ester group consisting with our H-NMR. And then over here, it is not that one because it does not have a double bond oxygen or just a regular oxygen. And then we can determine that our unknown is methylbenzenate right here. Next up, we have our IR spectrum. Alrighty, here we go. So first, I recorded an infrared spectrum of an unknown sample equipped with a spectrometer that the liquid was put on an ATR crystal. And then the sample was also tested at room temperature. And then the spectra were corrected for normalized as the presentation. All right, so now we're going to be labeling the spectrum here. So our first peak we're going to start off here is just below 3000. That is an sp3 hybridized. As you can see here, just below 3000. And then the next one we got is another sp3 hybridized. Similar like I said before. And then this interesting one we have here, about around 1715 wave numbers, is a C double bond ketone. We know it is a ketone because it does not have the correct spikes or peaks for carboxylic acids or for aldehydes. That's how I deduced it to be a ketone. So, like I said before, this is going to be a strong peak, usually very strong. And then that relates, as I said, to a ketone. The strong carbonyl absorption at, around 1750 combined with the CH3 stretches seem to match up to one of our groups in our group 6 molecules. I won't tell you just yet what it is, but you can have an educated guess. So next we're going to go through the elimination of why it wouldn't be either of these two compounds. So first, tocline is not going to be tocline because it does not have an aromatic ring. The peaks do not indicate this. And then it is not going to be bromopentene because of the lack of peaks that it shows. And the CH or the sp2 hybridized would be very abundant throughout the IR spectrum. And like I said, the absence of aldehyde, the stretches from 2720 to 2820, with the carbonyl eliminates, those from the ketone. So our final identification here, we can strongly confirm that is going to be 2-butanone because of the C double bond O and the sp3 hybridized, which yes, all 3 molecules have sp3 hybridized, but none of them have a double bond O. And since we know that, we can finally get the 2-butanone as our final unknown. And with that, our 2 unknowns, methylbenzenate and 2-butanone. Thank you for listening to my presentation, and I hope you have a great day.